everyone, it's Alyssa and welcome to You Can Learn Math. Today is about solving inequalities. Before we jump right into it, I want to do one little sort of side note here to set it up. Let's say I have, because I'm assuming at this point in your algebra journey that you have already seen some sort of straightforward equations with variables on both sides. Like say 6c plus 10 equals, 4c plus 16. Something like that. Does that look familiar? Show of hands? All right, hope it does. Because the process that we would use to solve these equations is incredibly similar to the process we would use to solve inequalities. There is one little nitpicky but crucial difference that we'll get to later. But first, let's just remind ourselves how we solve an equation with the variables on both sides. Anytime we have an equation in algebra, everything is like a seesaw or a teeter-totter. If I have two people sitting on the seesaw and they weigh the exact same amount, it's going to be perfectly balanced. It's equal. Now, if I were to give a box that weighed 10 pounds to this person, it's going to drop down. It's not balanced anymore. But if I gave a 10-pound box to the other person, hey, we're back to being equal again. That's our principle that we need to solve everything in algebra. If we do something to one side, we have to do it to the other so that everything stays equal. Our other goal is to get all of the variables on one side and all the numbers, just the plain numbers, the integers and such, just those plain numbers. Doesn't have to be integers. I don't know why I said that. You know what I mean, on the other side. And it doesn't matter which side they go on, we will still get the same answer. So for this one, I'm going to put all the variables on the left and I'm going to put our numbers on the right. Okay, so to do that, I want to get rid of this variable over here. Since this is being added, or it is a positive 4c, to undo that, to get rid of it, I'm going to subtract 4c from both sides. 6c on the left side, 6c minus 4c is 2c. Still have that plus 10. On the right, 4c minus 4c is 0, so that's gone, and I just have 16. Now I want all the numbers on the opposite side from the variables. I have all the variables on the left. I want all of the numbers on the right. Here I have a positive 10, so I subtract 10 from both sides. Keep that balance beam, or not balance beam, that teeter-totter, that seesaw level. 10 minus 10 is 0, leaving just 2c on the left. And 16 minus 10 is 6. Okay, so now I have the variables on one side, I have the numbers on the right. So it's 2 times c. If I want c by itself, I need to undo what's been done to it. So c has been multiplied by 2. The opposite of multiplication is division. So I'm going to divide by 2. That undoes it. I have c on the left, and 6 divided by 2 is 3. Okay, hopefully that looks very familiar, because now we're going to do the same problem, but just do the one little extra wrinkle. I'm going to change this to less than. All right. Does anything change? For this problem, if we do things the same way as we did the equation, we actually can do that. We can do everything exactly the same way in this particular problem. So again, same thing. I want all of my variables on the left. So I subtract 4c from both sides. 2c plus 10 is less than 16. I want all the numbers on the right, so I'm going to subtract 10 from both sides. 2c less than 6. c is being multiplied by 2. Go up there where I told you to go. Come on, whiteboard. Go along with me here. So I want to undo that multiplication by dividing by 2. c is less than 6 divided by 2 is 3. Now, when you're doing an equation, a way to check it is to put your final answer back into the top equation. We can do that with inequalities. And let's see if it works. C is less than 3. Now, pick any number in the universe that's less than 3. I'm going to pick 0 just because that's going to make things super easy. That's a very tiny 0. There we go. That was an abnormally tiny 0. All right, so 0, 6 times 0 is 0. 0 plus 10 is less than 0 plus 16. 10 is less than 16. Hey, it's true. So far, so good, right? So like, oh, why was I worried about this? Because I'm just replacing the equal sign with a less than or a greater than, and nothing changes. Ah, but you wouldn't be in a math class, or you wouldn't be coming to this video if there wasn't some catch, right? Right? Well, there is. There is a catch. It's not a huge catch, and it's easy to do. You just have to remember to do it. And because it's such a simple, quick little thing, it's very easy to forget about it. Say negative 3x plus 5 is greater than x minus 20. Oh, wait, no, let's not do minus 20. Let's do minus 15. There we go. Okay. So let's work this through, and let's do it exactly the same as the previous one, and you'll see why we can't do it exactly the same as the previous one. And so let's see if you can figure out what's going on here. All right, so first thing, let's say I'm going to get all the variables on one side, numbers on the other. So I'm going to subtract x from both sides. Gives me negative 4x plus 5 is greater than negative 15. Then I'm going to subtract 5 from both sides to get the numbers on the right. Negative 4x is greater than negative 20. And then I go, oh, okay. Well, now all I have to do is divide by negative 4 on both sides, and I get x is greater than 5. Woohoo, I'm done. Am I, though? Let's see what happens. What if I put something greater than 5 in here? Let's say I put 10. So negative 3 times 10 plus 5 is greater than 10 minus 15. Well, negative 3 times 10 is negative 30 plus 5 greater than 10 minus 15. Negative 30 plus 5 is negative 25. 10 minus 15 is negative 5. Ooh, it should be the other way. So what happened? What happened that made this not work? Well, what happened right here. It happened right over here. It's when we divided by negative 4. Because you see, if those numbers had been positive when we were looking at that over here, but we have the negative number, so negative 25 is not greater than negative 5. 25 is greater than 5. So it's when we divide by a negative or multiply by a negative, we have to reverse or flip that sign. I'll show you another sort of reason why. So as soon as we did this, actually at that point it's fine. When we divide by the negative 4, we have to flip it. Here's another reason why. I'll show you why. If I did the exact same thing, because remember I mentioned before, it doesn't matter what side the variables are on or what side the numbers are on. It's just variables on one side, numbers on the other. But it doesn't matter which side you're moving the variables to, you get the same answer. Well, and that's true when we're doing equations. Well, let's see what happens if we do it with this inequality. All right, what if I moved the variables that way and I moved the numbers to the left? Let's try it. What if I added 3x to both sides? Then I get 5 is greater than 4x minus 15. Then I would add 15 to both sides. Do you see what's happened? if you're viewing it like, you talked about like the alligator points towards the bigger number. Please tell me you know what you've heard a teacher say that before. The greater than or less than, the alligator points toward the bigger number. It's the small end of our greater than less than symbol. In this case, it is greater than, but the small side is pointing towards the x. Well, over here, before we reversed it, the big mouth of the alligator was pointing towards the x. You see how, because I've moved the x to make it positive, I moved it to the other side, and that put it on the other side of the greater than symbol. So now it's showing that 5 is greater than x, or x is less than 5. So we've done the same math, and if this were an equation, both of these would get you x equals 5, this would give you 5 equals x, and it wouldn't make a difference that we moved one to one side and one to the other, or that we did it the opposite way. But because it's an inequality, if you're moving to that other side to make it positive, now, you're on the other side of the greater than or less than symbol, depending which one is applicable in your case in that problem. So that is the big trick. That's it. Is just if you divide or multiply by a negative, you have to flip your symbol, and that's greater than, less than or greater than, less than or equal to, greater than or equal to, both of them. Either one, if you multiply or divide by a negative, you have to flip the sign in the next step. Like once you do that, you flip the sign. And that's not hard. Is it hard to just write it the other way instead of that way? No, of course not. What is hard sometimes is just to remember to do it. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.